Okay, why is it not there? It was there a second ago. Oh, it's because it's kind of looking onto itself. This may be a bit of a dry stream, but when a lot of conspiracy theorists and groups, they think like places like NASA or the Canadian Space Agency is faking space to hide the truth, or to show that there's a spherical Earth and there's outer space. So because they're trying to hide that there's a flat Earth. A lot of that's just BS, and some people actually believe it. But the thing is the Canadian Space Agency, it does a lot of work. It does a lot of the building of devices and paying for it, and training astronauts. And well, a lot of our astronaut training is done with the States because we don't have an astronaut program really. So a lot of the training is done down there. They probably have to pay the Americans a certain amount to train the astronauts. And we have a certain flat earther, I don't want to invoke his name, that thinks he's going to sue the Canadian Space Agency and going to get millions of dollars because that's the way he is. Yeah, I started a little early. Okay, but the Canadian Space Agency, he doesn't have much evidence of what he claims is proof. A lot of his photographs are bad. So that's the thing. And plus the thing is a lot of the funding for the Canadian Space Agency comes from other agencies, and like there's the National Research Council of Canada, and the National Science and Engineering Research Council of Canada, NSERC, which also provides a lot of funding. And they don't only fund space programs. These groups fund like medicine and environmental and chemistry research and all these other forms of research in Canada. Plus, the National Research Council also has their own nuclear reactors, which provides medical isotopes. And they just don't give out the money at random. Since there's actually a fairly limited amount of money for research, a lot of the research actually, the money you have to go through panels of scientists who are specialists in that area to get your research. So that's why they're that's why it takes something. Like, you can't just go up to the government, I want $5,000 to investigate the flat Earth. It's like Canada can't afford $5,000 to fund somebody to do flat Earth research because it won't provide the results that are needed. So, okay. No. Plus, another thing is they don't understand. This is probably going to be a very short stream today, but the rocket launch from Nord Space they have to reschedule for September. They have to get new licenses for launching things into launching, and that won't be until September. Okay, we're going to go through some of the stuff that astronomy and physics students have to take. These first three courses probably are actually for non-science students. The first one is Sky and Planets, and introduces the solar system and background science and mathematics, and they teach the celestial field, the night sky, and locating objects and motions. And then you have Stars and Galaxies, which is the continuation of the program of the course on the second term. And this is more like, the sun is a star, stars and star clusters and stellar evolution and nebulae, Milky Way and galaxies. And this is to explain the different things, and their homework consists of assignments and labs. Some of them require the Burt-Gaffney Observatory, and that's years ago. I took the images for these courses and for the first year astronomy students, or with their version of the course. And then there's Life in Space. This is actually, I think, only a web-only course now. And it can't be taken by the Bachelor of Science students because. And then you get the Introduction to Astrophysics, which is the more math-based and science-based version of the previous two courses. The measurement eclipses, telescopes, astronomical instruments, and the solar system. Okay, special topics, that's new, but I think that's because sometimes if you want to take a specialized part of astronomy, they probably use those ones. And then they have Foundation of Astrophysics. Observational quantities and positions and motions of stars, and like the emit topics include a review of the celestial sphere, astronomical catalogs. Okay, it's slightly different than what we took. The two-body problem, dynamics of star clusters, stellar spectrum, including emission and absorption lines. Okay, that's slightly different than what we took. And students are assigned observation projects and trained to use the Burt-Gaffney Observatory. We did that. We looking for asteroids. You take a bunch of pictures, and then hopefully there's a little dot blinking through them. Okay, I need a drink of water already. And you have properties of stars. These include determine stellar properties. I'm just reading them out loud. Classification, Boltzmann and Saha equations are figuring out densities of gases in the atmosphere. Okay, and more special topics. Interstellar matter and stellar evolution. We call this interstellar medium when I took it. About neutral and ionized interstellar clouds, so nebulae like the Orion Nebula and other ones. You don't talk about Pacific Nebula. You don't find you don't memorize the mass. You just they have the concepts and the formula, and then you have galaxies and cosmology. Observational astronomy. I think this used to be data analysis. A lot of it seems like we had a course called data analysis, and this is probably an optional course. This one used the Burt-Gaffney Observatory. The images that we used was images from the professor who taught the course, and it was about globular clusters, trying to find the age of globular clusters by using how many white dwarfs were in the cluster. More white dwarfs meant it was an older cluster, and high energy astrophysics and more special topics. That's the astronomy load. And then you also have the physics. And you have University Physics 1 and 2. And if it's like what I took, it's every week you're given like a huge thick textbook, and every week or two it's basically a new chapter in the textbook. And the first little while it's basic dynamics, vector calculations, gravity, and all that stuff. And fundamentals of physics. Okay. And then you have the scientific method. I can't remember this course being taught. It's also being taught with the philosophy department. and it's about historical and logical analysis of methods currently used in science, and it's jointly taught or by the two departments. And it also discusses science versus pseudoscience, which is good because there's a lot of pseudoscience, especially with U2, on the social sciences, and introduction to modern physics. And then you have the modern physics this is the beginning of like dealing with quantum physics, maybe spectroscopy, relativity, and nuclear physics. So okay, and then you have mechanics 1. This is about setting up equations about the one I remember was mostly static models. It's trying to set up equations about things going up and down inclined planes. So, but this is just to demonstrate what the students actually go through, and because they think it's some kind of like you memorize this and there are programs at university that are kind of like that, but this is like you're given a problem, you have to solve it, or you go into the lab, you got to do a lab and figure things out. Like the first year has a lab. Electricity and magnetism probably has a lab. The second year has a lab because it's basically circuits and figure out simple things such as resistors and induction and capacitors and inductors. Thermodynamics, that's basically how particles move and how gases expand and contract due to heat. Special topics, mathematical methods. Okay, math method. Well, they were just starting to teach computers, computational methods. When I was there, and classical mechanics. This is about orbits and Lagrange points and such things. And electromagnetism. This is more advanced than the second year one. And this one is heavy. I think it's more like surface integrals, and trying to figure out charges on the surface of stuff. Quantum mechanics 1, that's how the subatomic world runs its quantum mechanics. Okay, yeah. I'm going back, trying to find where I was. Okay. It's statistical mechanics. It's an extension of thermomechanics. And mathematicals and physics 2. And then you get to general relativity and quantum mechanics 2 and quantum mechanics 3 near the end. And the research thesis, this is for people doing an honors degree. Probably different in different countries. Here in Canada, if you do well enough, you get you do a thesis project and you get an honors degree. And then you move on to grad, and then if you do well, you can go on to grad school. And I know engineering is slightly different in Canada than most places. After you finish your degree in engineering, you have like an apprenticeship. I think it's like 4 years, and then you get P.ENG after your name, and you also they also give you an iron ring. So if you see an iron ring of somebody in Canada, it might actually, I'm just wondering if anybody's actually listening, but maybe this will sit in the thing for other people. But if you actually see somebody wear an iron ring, it means they have their PNG. The iron ring comes from collapsed bridge in Quebec, and it's to give them a little bit of humility. They could use it. But the thing is, there's also professional institutions in Canada for astronomy. There's CASCA, it's the Canadian Astronomical Society and Society of Canadian Astronomy, and they put it together for the acronym. But this is more of the Institute for Professional Astronomers. It's mostly professional astronomers and students. The fees, they can have quite high fees. I don't know what the fees are like, and they have like a meeting once a year, typically in a city that has an astronomy department. Like there's an astronomy department in Halifax. The last one was in Halifax. There's McGill. I don't know. No, McGill has an astronomy department, but there has to be one in Montreal. I think the University of Montreal has an astronomy department in their own observatory. You have the University of Toronto. They have their own astronomy department and observatory, and Alberta, the University of Calgary, and Simon Fraser University and UBC. There's Canada. A lot of Canadian astronomers actually have to go afield, like into the States, to become astronomers, professional astronomers. It's changing, but like when about 25 years ago, there was about 10,000 professional astronomers in the world, and about 6,000 were in the States. Besides CASCA, there's the American Astronomical Society down in the States, their main body, and there's the International Astronomical Union for naming things such as planets, comets, and all this stuff. They're the ones that do that. They're the ones that demoted Pluto years ago. They had a vote on it. There's, I think, about 25,000 members or something like that. But only a small group actually showed up at the meeting to demote Pluto. It was because there was other bodies found around Pluto, so it didn't clear its orbit, and they didn't want to have all these planets just all around in one area. Okay. And also in Canada, there's other groups. There's the Royal Astronomical Society of Canada. This is open to everybody. Professionals and amateur astronomers. Amateur astronomers are just people who don't do it for money. One of their main things, I don't know if they ship to the States or not, but public, is the Observer's Handbook. They've been publishing this for years. I think the same artwork has been on it for years too. But this is just a general issue handbook about what's in the sky and when to observe it and when to find it. Okay, I'm actually almost done here. I don't have much prepared this week because I was a bit busy. And right now, there's a guy doing a streamathon, Fight the Flat Earth, and he's taking a little bit of a nap, but I'm not going to cover his entire nap. And here we have the American Astronomical Society. Oh, cool website. They have a lot more members, but this is their professional organization. Okay, I know that was short. It was under 20 minutes, but I don't really have much. I didn't have much prepared for this week. Maybe more for next week. But that's just to give you an overview of how the institutions are and some of the work that's required to do that stuff. So, am I even streaming? Yeah, I am streaming, but a lot of people are probably busy this afternoon because it's Labor Day weekend. But this is just to give a quick brief of where people get their money and how it's done, and the work that's required just to get your undergrad degree. And once you're done your undergrad, plus the thing is a lot of undergrad programs and the grad programs but they hire students to do some of the teaching duties, such as marking or operating the telescope, and teaching labs and marking the labs. Because like the astronomy and physics program, there may be only a few students, but there's other departments that use the physics courses, like engineers, they have to take a certain amount of physics courses, or and so there's a lot of work and time. It's not an easy program to go through, and it's not just memorizing things. And actually, to get a doctorate, you have to increase the knowledge in your field. So I'm going to actually shut that down early. I have a few other things I probably should be doing. I hope everybody has a good day and goodbye, and hopefully see you next week at this time. And plus, the thing is also this week I did another stream about a rocket launch that failed. So that was over 2 hours. So I hope everybody has a good day, and goodbye. And I didn't record. Well, YouTube recorded. Okay, bye.